Hello students, and welcome to section 3.3, Properties of Logarithms. First we'll start with the change of base formula. Let a, b, and x be positive real numbers such that a cannot equal 1 and b cannot equal 1. Then the log base a of x can be converted to a different base using any of the following formulas. So base of b, we can see here again log base a of x. We can rewrite this as log base b of x, the thing that you're taking the log of in the first place, divided by log base b. Notice the same base here as b, but dividing that by log base b of a, the base of the original problem. So dividing that by that should yield the final answer in its full form. If the base is 10, same original problem, log base 10 of x. Again, there's the quantity or the expression you're taking the log of. Divide that quantity by log base 10 of a. So these two should result in the same exact value. And then lastly, base e. Log base a of x can be rewritten as natural log of x divided by natural log of a. We're going to go ahead and compute the following using a calculator. I have done a couple already here for you. So what we'll go ahead and do is we'll confirm this via the calculator as such. So for the first, and your calculator does have the ability to not only use the change of base formula appropriately or properly, but it also has the ability, for at least what you see on the TI-84 Plus, the ability to do a log base feature where you can actually literally use what you see in the original problem. So this first problem, already done, like I said, log base 10 of 50 divided by log base 10 of 6 is how you would rewrite log base 6 of 50. Remember, 6 to what power is equal to 50 is what you're asking the calculator to do for you. Now, we're going to start with log without obviously typing in the base. We can just assume there that it is in fact 10. It is in fact 10. It's the common log. Divide that by log of 6. So you do that, and in the end, the answer ends up being roughly 2.1833. We can check this by hitting 6 to that power and ending up with the following. So of course 6 to that number is in fact 50. As we discussed in the last section briefly, there is a button on your calculator. If you hit the math feature, scroll up to option A, log base. That feature allows you, if you have a TI-84 Plus, you can type in the base of 6 and of course the number you're taking the log of, 50, and the calculator should end up giving the exact same result. So log of 50 divided by log of 6, if you wanted, you could do this with any base. So for example, natural log of 50 over the natural log of 6. This should still work as long as you, of course, use the exact same base, noting that the natural logs and both numerator and denominator, of course, have a base of e. That should yield what we see, 2.1833. So for number 2, you're not actually calculating here, you're just setting it up. So log base 4 of x can be rewritten as log of x divided by log of 4, or natural log of x divided by natural log of 4. The base, of course, here is 10, but you could theoretically also write, well, any base such that the base, of course, a is not equal to 1. Okay, it can't be a negative number either, nor 0. But any number that technically is greater than 1 should work as a base. Properties of logarithms. Let a be a positive real number such that a is not equal to 1. Let n be a real number. If u and v are positive real numbers, the following properties are true. So the product property reads as such. Log base a of u times v is equal to log base a of u plus log base a of v. So the product of u times v can be expanded, we say, expanded as these two separate logs. Okay, notice we're using u and we're using v in a separate log, each you see having a base of a, log base a, log base a. The quotient property reads as such. So log base a of u over v, we've got log base a of u minus log base a of v. The difference based on the quotient, the difference of two logs is what we're looking at. The numerator here, u, ends up being the first quantity you're taking the log of, while the denominator the second quantity, and again you're subtracting, not adding. The same two properties apply to natural log. I didn't speak to it, but you can see natural log of u times v is equal to the natural log of u plus the natural log of v, so that's expanded as you see here. And of course natural log of u over v is going to end up as natural log of u minus the natural log of v, so we're subtracting as a result. The power property, log base a of u to the n, you can move the power out in front, so n times log base a of u. Similarly, you can rewrite this as, or notice that it can be rewritten as natural log of u to the n. N goes in front, as you see, n times the natural log of u. Now all of these results that you see on the right side of these equations, all of these results are expanding the single logarithm, but you can also go in the other direction. In other words, you can condense, we say. So expanding means to break up into more parts. Condensing means to break down into a single part or log. So please keep that in mind. Okay, so let's continue. On the next page, it does say, in fact, condense or expand the following using the properties of logarithms. So the first problem that you see, you have log base 10 of 10z. So we can certainly use a product property, or the product property, pardon, to expand this. And I know I'm going to be expanding because I have a single log and I'm going to separate it into two or more. And also technically it's 10z, so it I would argue pretty much speaks to the product property in application. So here we go. Log base 10 of 10 plus log base 10 of z. Now I also have just below designating, of course, that log base 10 of 10 is simply 1. Anytime you have a log or a set of logs that can be simplified, please do so. So simplifying further using the product property, expanding it out, but also simplifying, final answer ends up being 1, right, 1 plus log base 10 of z. Notice again my base is 10 in the end there on that second log. Number 2, this is another expand question, and I know this because you have a single natural log. Again, the base here is e. I also should highlight the fact that we're dividing two things, so the quotient property should very much be at play here. So let's go ahead and do that. We separate it such that the natural log of x minus natural log of x squared plus 1 to the 1/2 power. And I know it's going to be a half because the square root of anything is the same as raising that radicand to the 1/2 power. I have also made a denotation of moving, using the power property, moving, which I'll do in the next step, 1/2 in front. When you do that, you'll end up with natural log of x minus the 1/2 natural log of x squared plus 1 in parentheses. Please do not attempt to do anything more to that quantity. It's tempting, but be careful. These two terms are separated by this plus sign, not by a multiplication symbol or operation. So operationally, you're adding these two terms. You're not doing anything else, so you can't touch that particular quantity. Next, number 3, we have two separate natural logs, so we're going to condense or bring together these two into a single logarithm, natural log specifically. Notice also the 2 in front, I've got an arrow pointing towards the kind of back end of the problem, so we're using the power property in the other direction. Similarly, on this particular term, 5 can be moved out in the back end, so to speak, so it's from front to back, so natural log of z to the 5th power. And I would argue that's pretty obviously to the 2nd power. Power property as we condense at the beginning, of course. Now we may have to do more. So here we go. Natural log of 8 squared plus natural log of z to the 5th. Now, in terms of condensing, remember the product property, right? If you start with two terms multiplied, you can expand it out into an addition of logs or natural logs. In this case, we're going to condense using the product property, but going backwards. So instead of adding, we'll multiply. So natural log of 64 z to the 5th. And that concludes that final answer. No more work on that. We've condensed it all the way. Number 4, a half times this quantity, natural log of x plus y, plus 2 natural log of x minus 1, x plus 1, pardon, plus 3 natural log of x. I've already started the process of denoting the power property, which you can do here as well as there, noting this will be x minus 1 squared and this will be x to the third. And we continue, as you can see here, where I've noted that a half, parentheses or bracket, natural log of x plus 1, plus natural log of x minus 1, quantity squared, like I said, the power property is at play. And then, of course, here, plus natural log of x cubed, again, the power property. Keep in mind that the power property probably will apply in some way, shape, or form again, but not until we work with the parentheses. So I've already kind of moved my, my text box there, showing that you have, with this plus sign, another product property application. So natural log of x plus 1 times the quantity x minus 1 squared. Now I do show the arrow here in the next step, denoting that my next property and application will be the power property again. Don't do anything with that last term, of course, and just continue on, and at the end we'll see what we can do. Again, we're trying to condense everything, right? We're writing it as a single log or natural log. So here's the next step. I've moved the half out at the end there, so to speak, or the back end, so to speak, of the function first term. So natural log of x plus 1 times x minus 1 squared, the whole quantity raised to the half power. I'm still adding a natural log of x cubed, so there is another step, which, as you can see, I've performed for you already, the product property, which applies because this is a plus sign again. So this times that in full, as you can see, one single natural log of x plus 1, quantity to the half times x minus 1 times x to the third. Find the exact value of the logarithm without using a calculator. Okay, there are properties that we need to discuss yet again. Some reminders, really. E to the natural log base e, there's an e there, of x is simply x. We haven't seen exactly that version because, well, we've mainly discussed this particular version, which is really going to get the same result if you think about the bases here, e and e being the same. And as you see here, a and a are the same. So a to the log base a of x power is x, which is an inverse property technically of this. Log base a of a to the x is equal to x. Similarly, natural log base e of e to the x should also equal x. Alright, so this first problem, it's log base 6 of the cube root of 6. And because we can rewrite the cube root of 6 as 6 to the 1/3, here's what I've shown here in my next step. Log base 6 of 6 to the third. It should hopefully look very much like this. So log base a of a to the x, noting the bases of 6 are identical. Simply put, because that's the case, we can easily go right to our answer, simply there, of 1/3. Next problem, log base 4 of 2 plus log base 4 of 32. We do have the same bases here and here. The product property should apply in context. So we can technically multiply 2 times 32 as an option, which I did do, log base 4 of 2 times 32. You could also, though, simplify either log and go from there. I went ahead and I condensed by using the product property. And then I went ahead and did the math such that log base 4 of 64 is the next setup. And then you can simplify as such, because 4 cubed is 64. Log base 4 of 4 to the third, of course, is simply just 3. Noting again, the answer is just 3 based on, again, this property back here. Okay. Technically, sorry, this property. Okay. Last but not least, this particular problem, you can move the 3 in front or behind, so to speak. So natural log base e of e to the 12th. Because the bases are, again, the same, like before, we get simply our answer there to be 12. So it does model here, as you can see, natural log base e of e to the x, such that, again, because these bases are the same, the answer is just the exponent here, 12.